Okay, guys. All right. So today we're going to be proving the quadratic formula. All right. Follow me. We got three colors. Green is my favorite. Now, we know that a quadratic equation is in the form, or a quadratic expression is in the form ax squared plus bx plus c, right? All right. But we want the equation. We know we're going to make that equal to 0. All right? Because then we want to solve for x, right? And we're going to do that. We want to prove what I'm going to write up in this corner right here. I'm going to write the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's a quadratic formula. That is what we want to prove. So we're going to move from this to that. And I'm going to show you every step of the way. Also, take notes if you are going to be asked to prove this in the future, probably sometime in algebra or so. So we just want to keep it natural. No editing, no nothing. That's all natural math videos coming to you live from Jamaica. I'm kidding. All right, let's go. So to do this, what we're going to be doing, we need a coefficient of x squared, this term right here, to be 1. In order for that to happen, what we are going to do, we're going to divide the entire equation here by the coefficient of the x squared term, which is a. So let me pull purple out. My wife's favorite color, this one. We're dividing that by a. We're dividing that by a. We're dividing that by a. And we're dividing that by a. Because whatever you do to one side of the equation, you must do to the other side. Right? So, doing that, look what happens. A into a goes one time. So what we're left with here is just x squared. Over here, what we're left with is b over a. I'm just going to write that b over a times x. Same thing. And over here, we have c over a. And then 0 divided by a is just 0, just the same. So that's just equal to 0. Now, what we want to do is to complete the square right here with this expression on this side of the equation. And to do that, we have to half the coefficient of the x term, and then we're going to square it. Now, when you half something, as many recall, you divide it by 2, right? So when we divide b over 2a by 2, because we're focusing on this term, just so you see what's happening, we're focusing on that term right here. So we're looking specifically at the coefficient, which is b over a. Now we need to half it, which is, in other words, divide by 2 or multiply by a half. Same difference, right? So we're going to have b over 2a. That's what we're going to get when we divide this term by 2. And let me just show you how we got to that. If you got to this far in math and still don't know, I'm here to help you with that. Let me just show you how we got to this right here. Now, the coefficient of a is b over a. The coefficient of x, I should say, is b over a. So we got that. Let me write in a different color. Coefficient of x is b over a. Just like that. And we just made mention that when you're halving something, you either divide it by 2 or multiply it by a half. So we're going to divide it by 2 just to see how all that 1/2 thing come into play. So we're dividing it by 2, right? And we're going to represent 2 as a rational number. That's just 2 over 1. Just so that everything makes sense to you. All right, so we're dividing fractions right here. So recall, going back to elementary school or basic school or something like that. All right, let's go. So we have the dividend right here, right? So we keep the dividend. That's b over a, or in other words, we keep the first fraction, keep it just the same. We change the operation right here. or the operator from division to multiplication, and we take the multiplicative inverse of 2 over 1, which is 1 over 2, or some of you guys may know it as, we take the reciprocal or the flip, whichever one works for you, and that's 1 over 2, right? And you know now when you're multiplying fractions, it's just, you could simplify first, then multiply, but you could also multiply first, then simplify. So b times 1 is b, and a times 2 is 2a, and that's how we get to b over 2a right here. So we just have the coefficient of the x term, right? So let's get rid of this right here, some elementary stuff, and we're gonna rewrite that now. In the next line, we're gonna have x squared plus b over a plus c over a, right? What we're gonna do with that new term that we got just now, remember we need to have the coefficient of the x term and we need to square it, right? So this term right here, what we're gonna do is we're gonna add it as well as subtract it. So it's like adding 0, right? But we're representing 0 with a whole expression, right? So we're gonna add b over 2a all squared, and we're gonna subtract also b over 2a all squared equals 0. You see that? That way, if you look closely to this piece right here, if you look closely to this piece right here, that's just 0. We actually didn't add anything, right? But we need this to help us to solve this equation. All right, so let's go. We're gonna clean this up a bit. We're gonna put all the constants, right? The constant term. Well, not the constant terms, but what we want to do is to isolate the variable x, right? That is our goal. And see, I missed the x right here also. That is our goal, to isolate. So we're going to take all the terms that are not of x, right? So every other term, we're going to take to that side, right? Except for this term right here, right? Because we want to make a perfect squared expression on this side of the equal sign, right? So, which means that I'm going to highlight those in red. We're going to move this term right here, and we're going to move this term right here, right? Those two terms in red. Now, let me show you a shortcut. On this side, it's positive. So when you fling it over to that side, it becomes negative, right? So we're going to move that over to that side. This right here is negative. So when you fling it over to that side, it becomes positive. So let's do that. Let's clean it up down this side. So we're going to have x squared plus b over a x plus b over 2a all squared equal, remember we're moving that to that side, which is negative c over a, and we're moving this to that side, so we're going to add b over 2a all squared. See that? Coming nicely. So that's what we did. We just moved this and this to that side of the equation, right? Now, what we're going to do is, what we have over on this side is a perfect squared quadratic expression right here. A perfect squared. So what we're going to do is we're going to write this. We can simplify this right over here as x plus b over 2a all squared, right? And I could expand that out just to show you that we would get back all of this right here. But that's not necessary, because if you got to this point, it means that you know something about algebra, right? So that's just x plus b over 2a all squared, right? So remember, we have the coefficient of x, right? And that's what we have here, and we squared it. That's what we have here, and we have x right here. So the two square terms right here. And we take the sign in front of the x term. That's this sign right here. That's why we have a plus sign. So we got a perfect squared expression right here. And if you were to expand this right here, you would get back to this expression right here. You could go ahead and do that in your spare time just to see that that is true. And then over on this side, what we're going to do, we're going to simplify over that side a little bit using some properties of exponents. And then we're going to add the fraction. So we're going to rewrite that as equal to negative c over a plus b over 2a all squared. Right? There we go. So now, from this piece right here, we're going to bring that up. We're going to use purple, the next favorite color. So we're going to bring this purple, we're going to bring this line all the way here, and then we're going to work our way down just the same. So we have on this side, we have x plus b over 2a all squared is equal to negative c over a plus b over 2a all squared. Right? Now remember, the goal is to get to what x is equal to. And we'll deal with this side in a few. Let's just clean up that side first. Now, we have a fraction here and we're squaring the entire fraction. It's the same as squaring the numerator divided by the square of the denominator, right? So this would be equal to, we're just going to focus on this side for now. We're not going to touch this side as yet until we're finished simplifying that side how we want it to be, right? So we're going to have negative c over a, and that's going to be plus b squared all over 2a all squared. See that? And again, we can simplify that 2a all squared would just simplify to 4a squared. So that's just 4a squared, right? Because then 2 squared is 4 and a squared. And we got that. Now what we want to do here is to just add these two fractions, and we're going to use the LCM method to do that, right? So to do that, in the next line, we're going to have the LCM, which is 4a squared, right? Because a can go into 4a squared, and 4a squared can go into itself. So the LCM, lowest common multiple of that, is 4a squared. And then a, divide that into 4a squared. Remember, when you're dividing exponential expression of the same base, you know that base a, what we do, we subtract the powers, right? So 2 minus 1, we're going to just get a, right? A to the first power. So this is just going to be 4a. And what do? We multiply that by the numerator here. So we still have that minus sign, so it's going to be minus 4a times c. That's just 4ac. Sorry. And now, here we have 4a squared into 4a squared, which is 1. And 1 times b squared is still b squared. So we're going to add b squared to that. And what I'm going to do here in the numerator of this fraction, I'm just going to switch this around so that we don't have the negative out front here, right? So we're going to put the negative over to the right and b squared out front. So let's just switch this around. So we're going to have b squared minus 4ac up top. So we're going to have b squared minus 4ac. Nice. And you can see that it looks, in the numerator here, looks like that. We're getting there. Now, on this side right here, we're going to take care of this side right now. So I'm going to write this side out here, right? Now, we have x plus b over 2a all squared, right? Because that's the same thing coming there. Now, we need to get rid of the square and the exponent right here of 2, right? And to do that, we're going to take the square root of both sides. Changing color again, back to red. Let's go. So we're going to take the square root of both sides. So we're going to take the square root. Let's just move this little line right here and probably fix it like this, and coming around and meeting that back right there. So we got a little space right here. Nice. Okay, great. So we're going to take the square root of both sides. And when we do that, look what happens. The square term right here, this 2 cancels with the square root, right? Because the inverse operation of squaring is square rooting. So what we're left with is x plus b over 2a. So we're going to put that, going back to purple, that's x plus b over 2a. Good? And that's going to be equal to the square root of b squared minus 4ac over 4a squared. Now, remember, it's the square root of the entire fraction, right? So we can rewrite this as the square root of the numerator divided by the square root of the denominator. That's exactly what we're going to do. So we're going to rewrite this as b squared minus 4ac over 4a squared. And remember, square root sign goes in red. So we're going to square root. See that? So that's the same as square rooting the entire fraction. Now, what we're going to do here is take the square root of the 4a squared right here. And as you can see, we're actually going back to this step right here, that 2a, because the square root of 4a squared, right, is 2a. Because it's the square root of 4 times the square root of a squared. And the square root of a squared is just a, and the square root of 4 is 2. So the square root of 4a squared is just 2a. So what we have on that side is just, this is going to be equal to b squared minus 4ac all over 2a. And don't forget, the square root is right here in the numerator just the same. We just take the square root of the denominator, which brings us to that piece right here. And on this side, we still have the x plus b over 2a. I know you're seeing it right now. Remember where we're going. This is where we're going to, right? Now, we need to get x, right? So we need to isolate x, right? So we need x only on this side. X wants to be by itself, just like this one right here. So to remove this from this side, we need to subtract it, right? So I'm just going to do that right up here so you can see it clearly. So let's remove this piece right here. Hope you got this. Hope you took that off, right? Let's go. So we're going to move this piece right here. And we're going to bring this piece right here all the way over here. So we're going to have x plus b over 2a is equal to b squared minus 4ac over 2a. And don't forget your square root right there, just for the numerator, not the denominator. And we're going to bring this piece over here now. So again, it's positive on this side, on the left-hand side. So when we take it to the right-hand side, change sign, it becomes negative. So we're going to have x only on this side is equal to the negative of b over 2a plus b squared minus 4ac all over 2a. And don't forget again the square root in the numerator. Now, these two are fractions with the same denominator, 2a, 2a. And we all remember how to add fraction with the same denominator. We just keep that denominator, which is 2a. So here, in this line right here, x is going to be equal to, we're going to keep that denominator of 2a. And we're going to draw that line. See that? Now 2a into 2a goes one time, right? And I could just keep that and just add the numerators, right? So I could just write that back. But I'm going to show you why. 2a into 2a goes one time. 1 times negative b is negative b. Plus 2a into 2a again, one time. So we're taking this the numerator here, which is the square root of b squared minus 4ac. And this time I'm just going to write the square root in purple because everything looks right because we're getting the final answer right now. So we're taking the square root of b squared minus 4ac, right? Now, as you can see, we're missing one thing, and that's the minus sign right here. That's what we're missing. And we could have put the minus sign from this piece right here. We could have put plus or minus right here. And why? Where's the marker right here? Why we could have put plus or minus from here is because the square root of any integer, right? Or the square root of any number will yield two values, both positive and negative, right? So the square root of a number, let's erase right here, will yield two numbers, a positive and a negative. For example, the square root of 4 is equal to plus or minus 2. Because 2 times 2 is 4, and negative 2 times negative 2 is 4. So that is why when we take the square root of this side, it's not only going to give us a positive value, but also it's going to give us a negative value. And that is how we have the plus or minus right there, because we have two answers to that square root. And I think we are done here. Because as you can see, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 here, which is equivalent to what we have up here, which is exactly what we wanted to prove, right? Hope I did great. That's it. Thank you for watching.